So, oh wow, there's a lot of people online. Jackie's here now, Megan's here online, Lee. That explains why the class is somewhat empty today. So right now I'm checking to see with the people at Alex how I can open up all the assignments like sometime next week, so that anything that you have worked on in the past, maybe if you worked on it late with having a new due date that's up in the future, should give you full credit and also give you time to get caught up since we are nearing the end of the semester. I want to make sure that if I know how to do it, but I want to make sure that if I do it, I just didn't fucking open Pandora's box and I can't put the shit back.
Right.
Like, am I gonna fuck the whole program up if I do it? It works great on like my math lab with Pearson and other things, but with the way Alex does all its stuff, I want to make sure it's not gonna fuck you guys, because we don't want to do that. All right, so that's what I'm looking into doing. I've already emailed. She's at a meeting. She'll email me back. Day 22. What we're aiming to do today is 13.4 nonlinear systems. 13.5 is inequalities. And I am confident that I can blur 13.6 in with it. And then we don't have any video to watch on Tuesday. Because I was just doing it with the Math 335 group before you guys got here. And they did a system of inequalities and they said they got it. I gave them a problem to do and they got it. The inequality part is that hard. All right, so 13.4 nonlinear systems. These are systems of equations that are not just straight lines. Eventually, people are going to stop using the word straight lines with you when they say lines, because in mathematics, line implies straight. If it's curved at all, it's called a curve. If it's curved just in one spot, and it goes fucking flat the whole fucking way, and then it curves up at the end for some fucking godforsaken reason, it's called a curve.
You know, to be fair, I think, and I thought about that, and honestly, I'm like, I think when people are saying the word straight line, I think they mean something more like adheres to X or Y axis. But where it's like, it's not, it is straight, but it's not, it doesn't have a slope, like with the whip for where they're looking at the thing. You're like,
Maybe.
Dude.
X squared plus y squared equals 25. Y minus x equals 1. I suggest you give it a quick sketch. X squared plus y squared equals 25 is what? What is that a graph of? He's not here to do all you guys talking for you.
I know.
Someone's gonna have to.
Circle.
It's a circle with a radius of what? 5. Centered where? At the origin. So from the origin, I'm gonna go up 5, left 5, down 5, right 5, and assuming I did this all right, that's my circle. So that's x squared plus y squared equals 25. Y minus x equals 1. If I solve this for y, I get y equals x plus 1. which has an intercept of 0, 1 and a slope of 1. So I'm gonna have two solutions here. It's where the line and the circle intersect. Just like when we did two lines and we were looking for where the two lines intersected. Now we're just looking where the two graphs themselves intersect.
Well, will it ask us for intersections? It'll say like, find the intersection between these two things.
It'll probably say find the solution
Find this, that's what.
of this system of equations.
Not like an inequality of. Like where it's sometimes it's the circle and sometimes it's the line.
No, yeah, it's both. For a system of equations, it's both.
The 2 points work.
So it's only the 2 points. So I think if I had a good graph, I could do them with a graph, but that's not how we roll. We're gonna do shit mathematically. How did we do systems of regular equations? We could do substitution or the elimination / addition. I don't know that adding or subtracting anything here is gonna be nice. That's weird shit going on. But I can do a substitution method. In fact, substituting y into this equation up here should go pretty well. I'm gonna have x squared plus x plus 1 squared equals 25. So if I work that out. And I'm gonna subtract the 25 over right now. Combine some like terms. And anyone notice anything nice about this equation? They're all even, right?
Yeah.
So if we take out the 2, that should be a square right there. And if I divide by 2, that shit goes away. And that's factorable.
That's.
So I get from this one, x plus 4 equals 0, so x equals -4. Or from this one, x minus 3 equals 0, so x equals 3. We need the y value though. So y equals x plus 1 is -4 plus 1, which is -3. I have the point -4, -3. Which looks like what I have. I actually had a decent sketch for once. So here I got the 0.34. Not bad. What's the cursing for, Davis?
Yeah, it's wild to me. Oh, I don't know. It just, I have heard tell of the usefulness of the circles in general. Here's another use.
The circle just is, it could have been any equation here. Like a parabola, I would have still had,
Fine. Yeah, there's a whole bunch of.
yeah, there's a whole bunch of options here. The uses of circle, yeah, the next class, Math 154 is pretty important throughout all of math and science and physics. It's a shame we're not gonna be teaching it soon. right, so I got 2 points. I should check them. I know that the solution has 2 points, so I'm feeling pretty fucking confident. Cause I grabbed it and I saw there was 2, but we should check it. So if I check -4, -3. -4 squared plus -3 squared equals 16 plus 9, which does equal 25. And if I check it in the second equation, -3 minus -4 equals -3 plus 4, which does equal 1. So it meets both of the 2 blue equations. And if we try 3 plus 4, or 3 and 4, x is 3, y is 4, 3 squared plus 4 squared, 9 plus 16 is 25. So it meets the first equation. And then I got y minus x is 4 minus 3. That does equal 1. So it meets both equations. Now you should be able to graph these by hand, but sometimes they're a pain in the ass. If you're wanting to do this at home and work on these and just verify visually, you can plug most damn near every fucking equation into Desmos. Plug in 2 of them and just see where they overlap. Yeah, but you should always, when you're doing it by hand, verify your answers by checking the solutions. Any questions on that? That one's not too bad. Anyone need that up longer? All right. Why not I give you guys one to try? And we'll do it together in 6 or 7 minutes. I'm gonna sketch it while you're doing it. So I just grabbed them. Since the graph actually they intersect on the axes, I can see and know for certain what the answer is going to be. But you should still follow the method to do it. Now, something to think about. Don't solve all the way for y, for x. Maybe I should have done this one with you guys. Notice that if I squared 3x, I would get 9x squared. Or if I squared 2y, I would get 4y squared. I could solve for either side of these, but not get rid of the coefficient. And just square it. And plug that in directly for the 4y squared. Does that make sense? So let's take a look at this. I'll do it for the 3x. So 3x equals negative 2y plus 6. I'm going to square both sides. Now I have 9x squared equals, I don't know, I gotta multiply that out. I don't know what that is. It's 4y squared minus 12y, minus 12y is minus 24y, and then plus 36. I'm going to replace this here with this here, because they're both 9x squared. And then I'll use the other color to just keep it. I'll use black from the original. So that's after the substitution. Yeah,
What if we solved, or what if we took the equation, or what if we took 3x plus 2y equals 6 and solved for y?
then you would be replacing the y,
Yeah, replace the y.
and you would have a 9x squared, and then plus I don't know, let's see.
It goes down y.
If you'd done the other one, you would have had negative 3x plus 6 squared. So 9x squared
Or you'd have.
minus 36x plus 36.
You'd have needed 3 times x plus 3.
Oh, if you just solve for x.
Yeah, if you just solve for x using the square.
Okay. Are you sure x? 3 house would be y.
3, wait, so y, it would, we have to move the 3x over the other side, negative 3x plus 6, and you divide by 2.
So you solve for y.
Yeah, you solve for y.
So if we squared that, you get y squared. Is something with fractions in it. That's what's making me go, eh.
I'm with you.
Do you like it, right?
Yes, yes.
I don't wanna do it, so like backpedal, if you get to something like that, backpedal step, go, what if I multiplied by 2 and I squared it? Wait, that should have been a 3 there. If I multiplied by 2 and squared it, we're back up to what I'm doing up here.
Okay.
Substituting for y. But you could. This is 9/4 x squared.
It gets hairier.
Minus 18/2 is minus 6x. Plus 9/4 or 9/2 times 9/2 is 81/4. It does get hairy.
And well, and so I dropped it into the original equation instead of adjusting the equation. So
Yeah.
I got a little hairy for sure.
You'll notice this one, if I subtract 36 from both sides. And I add the y squareds together, I get 8y squared minus 24y equals 0. So it is easy. Factor out an 8y. 8y equals 0 or y minus 3 equals 0. So y equals 0 or y equals 3. And I'll plug it in up here. 3x plus 0 equals 6. So x equals 2, and I have the point 2, 0. I plug in y here, I got 3x plus 6 equals 6. So x equals 0 when I'm done solving, and I got 0, 3. I do that right, -3 half, I'm looking at over here. -9 halves times 9, -9 halves is 81/4. Which makes me think I did this wrong. I replaced x instead of y, never mind. Yeah, that's why I have it to lower values. Alright, so you can check your answers above both equations, they should work. Just in the interest of saving time, sure to check your answers, you need to do this. What, Davis?
Well, I'm like, I think I did something wrong, which is I solved the initial top left equation as an ellipse.
It is an ellipse.
Yeah. So,
I'm doing that here,
it is happening.
that was how I could sketch it.
I see it.
Yeah, if you try to work with the ellipse form that we have for graphing it. Now you got fractions in it, it's about ugly. Ugly AF. Alright. Why don't we switch to 13.5? Cause these nonlinear systems are gonna come up in 13.6 also. But we're gonna do more with them there. So let's switch gears to 13.5. 13.5 is on inequalities, linear inequalities. X minus 3y is greater than or equal to 3. 3x plus y is less than or equal to 0. We'll do them separately. Two different graphs. What?
I need to put the line on the bottom of the inequality first.
Why didn't I?
Yeah, because you said greater than or equal to.
I said the wrong words. Let's just go with this one. I want to show both cases. So, rules. We're gonna graph normally as if it's an equal sign. But with a single caveat. If it's greater than or less than, we're gonna use a dashed line. So, I don't know, if I solve this for y. I have -3y is greater than -x plus 3. Divide by -3, I get y is less than 1/3 x minus 1. Remember, if you divide by a negative with an inequality, you gotta change the inequality. So if I were to graph this. I have a y-intercept of -1. And a slope of 1/3. Rise 1, run 3. Rise 1, run 3, go down 1. The other way. Now, since it's strictly less than or greater than here, but less than here. I don't have an equal portion. I'm going to use a dashed line. Here. All right, next part of the rules. So that's part A. Part B. Pick a test point not on the line. Or curve, whatever it is. 0, 0 is the best if it's not on the line. Because it makes it so you can do the math real quick. Plug that point in. Into the inequality. And I would use the original inequality. If you divided by a negative or something, you might have fucked that up. So use the original inequality. Plug that point into the inequality. If it works, shade on that side. If not, shade the other side. Okay, so where is 0, 0? Right there. If I plug in 0, 0 into the original equation, 0 minus 3 times 0 is 0. Is that greater than 3? No. It's not greater than 3, so I'm going to shade on the other side of the graph. So the solution is any point in the shaded region. Not on the line though. Because the line is dashed, which means we're not including it. The line was representing the equal portion, and since we don't have an equality, that would be like saying 0 is greater than 0. Which is still false, so we don't include it. So here it's just it's making a boundary.
This is the line form of the open circle.
Yeah. That's exactly what it is. This is the open circle point version of the line. All right. What about this one? I get y is less than negative 3x. So I have a y-intercept is 0. X-intercept is 0. And slope of negative 3. Down 3 over 1, down 3 over 1. And now since this is less than or equal to, I can't shoot with my arm. I'm going to use a straight line. All right. 0, 0 is on the line. I can't use it as a test point. So I'm going to pick something else that's good. Other good options are 0, 1, 1, 0, or 1, 1. You know, pick values when you plug them in, there's math. You're not needing a fucking calculator. So let's go with, I don't know, 0, 1. Where's 0, 1? I'll go 1, 1. If I plug in 1, 1, I get 3 plus 1. Is that less than or equal to 0? No. So I'm going to shade on the other side. If it was true, I would shade on the right or above. As it is, I'm going to shade on the left or below.
So if it's no, it's either on the left side or below it, in that case for the other.
If it's no, it's on the side that doesn't have your test point.
Oh,
Does that make sense?
So
okay, yeah, makes sense.
Guess what? How is this?
it's not bad.
It's not too bad. The only thing that's really new is the dashed line and the shading. It's not too bad. Guess what? 13.6 puts them together. We're gonna jump to 13.6 and then we'll do all this shit in 13.6 using a bunch of problems from us. So now you're looking, you've got two curves or lines and shaded regions. You want the regions of overlap in the shading. I'm gonna resketch those two lines on one graph. Wait, you guys are writing it down. And I'm gonna be kind of lazy with my accuracy. That was my x minus 3y is greater than 3. And my y was less than 3x. Or 3x plus y is less than 0. Went like that. All right, now what I recommend doing here is because shading can fucking dirty your graph up pretty bad. So what I would do is use 2 different symbols, or even if you do like. We're doing the test points on each. So for the green one, we saw it was below. I'm gonna put little plus signs below the green dash line. And I'm gonna make sure I do them on both sides of that blue line. And then for the blue line, it's to the left. I'm gonna do the same thing, but if I'm like using a pen or a pencil where it's the same color, make them so they look different. So here, I'm gonna do like plus signs, but with a circle. Don't need a lot. Now you're looking for the region that has both symbols. The region that has both symbols is down here. Not a big step to go up, is it? 13.6 doesn't really add a whole lot. Yeah, it's just doing the overlap. Let me give you one to try also with lines. Before we start switching to other curves. Because this stuff works with other curves as well. So why don't you guys try? Oh, I don't know. X minus 3y is less than or equal to 6. Y minus 2x is greater than -1. 2x minus 1. Starts at -1 and you rise or run 2. Zero, zero is not on the line. So 0 minus 0, is that greater than -1? Yes.
no.
What?
No, I'm just saying like, yeah, it would be greater.
Yeah, so I'll put little plus signs over here. One third x minus 2. So down 2, rise 1, run 3. 3, and I'll go the other way, run 3. And this has a solid line. Because 0 in the top one. 0, 0, 0 minus 0 is less than or equal to 6. Yes. So I'm shading above it. Maybe I'll make x's rather than pluses. So the region that has both. Upper left region, right? It does include values on the blue line right here. It does include those values, but not the ones along the red line right there. All right, let's take a 5 or 10 minute break. It stops. Let's try sharing again. There we go. All right. So let's kick this up a notch. A little bit. Well, not kick it up a notch. Let's do one together on the next one. Talk about what's going on here. We're gonna have x minus 3y is less than or equal to 6. And 2x minus 6y is less than or equal to 12. Or greater than or equal to 12. Let's do greater than or equal to 12. So why am I picking shitty numbers like this? Let's change this around. Let's make this 3x minus y less than or equal to 6. We're gonna do 6x minus 2y is greater than or equal to 12. That way, when I solve, I don't have fucking fractions. Fuck fractions. When I solve, I'm gonna have y is greater than or equal to -3x plus 6. And when I solve here, I'm gonna get y is less than or equal to -3x plus 6.
It's -6 on. Because we had to divide by name.
Ooh. Yeah, they should both be minus. They're both minus. Good catch. I'm like, what did I do? It should be the same fucking line, and all of a sudden they're not the same line. No, I just fucked up on both equations. All right, line A. Got a point there, a point there, a point there. It is a line that exists, so I'm gonna make a solid line. So for equation A, if I try 0, 0. I have 0 minus 0 is less than or equal to 6. That's true. It's telling me to shade over here for region A. Equation B. If I plug in 0, 0. I have 0 minus 0 is greater than or equal to 12. Which is false.
Yeah.
So I shade on the side opposite of 0, 0. What's the solution here? The solution is just the line.
Because they're both.
They both have the equal portion to it. So that would be y equals negative 3x plus 6 or minus 6 is the solution. If one of those was a strict inequality, like less than or greater than, we'd have no solution. That's deep.
That would be like saying. Whatever these two effects are,
They're opposite.
they're opposites, yeah,
Yeah.
they never occur at the same time,
They never occur at the same time and they don't even agree,
they don't.
like one's on and one's off. It'd almost be like an on-off switch. When it's on, it's the green side. When it's off, it's the blue side. And like if the blue was the inequality, if it just said greater than here. Like when it's off, we're turning it off, it says not even counting the blue. Yeah,
Let's say. Both of these lines were dotted, would there still be a solution?
yep.
Yeah, okay.
That's what.
That's a good question though, yeah. All right, let's kick it up a notch. Let's start doing nonlinear systems of inequalities. So here we're gonna do the graphing and the shading, which is part of 13.6, but we're also gonna find where they intersect, which is like more practice for 13.4. Sound good? Yeah, because that's how we do it here. Let's go with. I'm gonna say greater than or equal to. No, let's do less than. Less than or equal to 9. And let's do XY is greater than 2. Okay, so. I'm just gonna do a quick sketch, so let's see what's going on here. What's the equation on the left?
circle. Radius of 3.
Circle of radius 3. I have a solid line because it's got the equality sign. So this is equation A in red. And where am I shading? Inside the circle or outside the circle?
Inside the circle.
So it's inside the circle. So all the region inside the circle.
Lines,
What?
or plus lines.
Yeah, all the possible, as well as the border of the circle. Here, if I do y is greater divided by x. When x equals 1, y equals 2. Let's see, which is just under the circle right there. Sorry, that's when x equals 1, y equals 2. When x equals 2, y equals 1. It does some shit like this. And it does the same thing over here. But it should be dashed line, my bad. Should be dashed. I can't plug in 0, 0 here to test the blue line. Because it doesn't tell me like, well, here, 0 times 0 is silly. Here it kind of breaks it. So maybe let's try, like, I'll try 0, 1. And no, I'll try 1, 0 and maybe -1, 0. See if being on the different sides of this asymptote makes a difference. So 1, 0. If I plug it in, it says 0 is greater than 2. Which is false, and if I stick in -1, 0. It also says 0 is greater than 2, which is false. I stick them into that one. So we don't, we want this region over here. And this region up here, the ones that don't include those points. And technically, right there.
So it'd be just those like just those little gaps in.
It's just those little wedges right there. But not the upper half, not the line on this one. And not the line, the bottom line on that. Okay?
Yeah.
So that's how the systems of inequalities would work. Let's find where they intersect. So where do these two intersect?
4 intersection.
Sure looks like it, right? Which is weird because that's a squared. So I can't do addition and or elimination method between the two. I'm going to do a substitution, so I'm going to actually just use the one I solved for to graph it. I'll take that and plug that in up here. And I have x squared plus 2 over x squared. I'm going to say equals 9 because we're checking to where to see where they equal. So the inequality isn't important here. Just for checking the intersections. So this is x squared plus 4 over x squared equals 9. I'm gonna multiply through by x squared. This is not technically the best way to do it. You're supposed to get a rational, like, but we already know x equals 0 doesn't work. Because it's on the asymptote for the graph. We already know it doesn't work. Actually, yeah, I do know that. So what I'm gonna do is get a common denominator by multiplying this by x squared over x squared. And that by x squared over x squared. So I get x to the fourth over x squared plus 4 over x squared equals 9x squared over x squared. And if I get them all on one side, this only equals 0 when the top equals 0. And we're gonna make a note that x cannot equal 0. Oh, we did some shit like this before, didn't we? What does this look like? What? Which probably is a nightmare.
Is this the thing where u equals x squared?
Yeah, they look like it's quadratic in form. If I say u equals x squared. Then u squared is x squared squared is x to the fourth. And this becomes u squared minus 9u plus 4 equals 0. Again, the bottom does not help us solve for 0. So we're not even gonna worry about that. So u equals, I gotta do the quadratic formula here. 9 plus or minus. -9 squared. Minus 4 times 1 times 4. All over 2 times 1. That's 81 minus 16 over 2. Let's see, 81, 71, 65. But we didn't start with you. Now ain't that a motherfucker? Cause when I take the square root of this, what happens? I get x equals plus or minus the square root of 9 plus or minus the square root of 65 over 2. So I have 4 values here for x. I have the positive, I'll do both positive here. I've got 9 plus square root of 65 over 2. That's my first set. Then I've got 9 minus square root of 65 over 2 is my second set. I don't even know what the y's are. And then I got the same thing, but with a negative sign out front.
There's no room on 965.
What?
Yeah, there's,
Ah. Okay. Well, what are you doing? I see 9 and 65 everywhere. What are you talking about? And to be a lazy fuck, I'm gonna say y1, y2, y3, and y4. Yeah, here I would probably get a decimal form. And then I would use the decimal form in y equals, so get a decimal. Plug into y equals 2/x. So you get your other decimal. And you'll have 4 points. Oh. Ah. You know what's funny is because I could have used a number that worked, but I wanted the circle to look nice. So I changed the circle to have a perfect radius. And that fucked up finding the regions of intersection. Made it shitty. But I meant the x's are really close to 0 and really close to 3. Because they look like it on the graph. All right. Let's try another one.
And just find the points and just kind of back in to the equation of y, the easiest equation of y. After they go.
Yeah,
So,
let's do y is greater than or equal to x plus 1 squared minus 4
would we get in trouble if we approximated to a whole number?
to a whole number? Yeah.
Yeah.
You should maybe go to a couple decimal places, 2 decimal places, maybe. As long as it doesn't look like 0 anymore. That seems like 1. And maybe we'll do uh, let's see. 3x plus y is less than 2. You guys try this. It's a parabola and a line. Hopefully you know how to graph this. Yeah. Keith, you missed it. Keith always giggles when I fart. So I try to include him in on it. Because sharing is caring.
Yeah.
So you're doing two things, you're grabbing it, finding the region that counts. And then you're gonna find the points of intersection. I guess I should write that.
This is. In a way, kind of a trick question. Because there is no point of intersection. Right? Because the.
I just made up the equation, shit. Really?
Because it's not equal to.
No, ignoring that, the inequality.
Oh, okay.
So where did the actual, where do the boundaries intersect? So maybe I'll say that, and the points of intersection of the boundaries,
The boundary.
because now you can still do it.
Right.
I'm like, there's no way. I'm like, I know where that problem is. I know they fucking cross. I know they do.
But I mean, to the original question, it would be that would be the case though, because. Because they would not technically cross in the actual set of possible points. Like
Right.
in the included region, that would
Right.
actually be an intersection. That was.
But like 12.4 and 12.5 is not gonna have you doing the, or 13.4 is not gonna have you do. There's gonna have you find the points and they're just gonna say equal signs. And then 13.5 is gonna have system inequalities, but they're just gonna be fucking lines. So, but here we're getting practice on both. For 13.6, which has the graph. It seems like a good test problem. I can literally test half the fucking chapter here with one fucking problem. And now I know I have to fucking put the words of the boundaries in there. Davis is gonna go, they don't fucking intersect. And you go, ah,
Feel like now I start sweating in my chair.
This is what I'm gonna do for the Alex homework. I'm gonna send out a survey. That asks you, do you want me to open up all your homework? For the entire semester due on the final day? If you want me to, which most students will, say yes. If you've been keeping up on your homework and you've been doing all your homework, like Keith has, like I'm sure Heriberto has been doing. Opening it up is gonna make all those modules appear and it's gonna make it harder to find the modules you need to still work on. That's the downside of opening up all the homework. Anything that you're behind on that you didn't do before, those are all gonna pop up as shit to do. And it's gonna make it harder to find shit like what we're doing today, what we're doing next week. So I'll put that in the email and just have a little survey. And ask. Or I can wait to do it until. May 9th or May 7th. The reason why, let me show you the syllabus real quick. So on May 2nd, we're gonna be doing 14.4, which will be on the final exam. Chapter 15 is not gonna be on the final exam. You don't have a lot of time to do the homework for it.
I'm prepared.
I mean, you technically have the time, but like doing that with the review, it's just a little too much. I am still gonna teach it, it's worth having seen, for when you get to later classes, it'll look fucking familiar. And if you've got time, you can practice somewhere then, but if I wait to open up till like the 7th. Then you'll have had time to work on all this, like if you work on it. If you don't wait till the fucking 9th, if you work on it before class on the 7th. You'll have everything through chapter 14 done, and then anything I open will just be old shit. And that way, anyone that's still working on it, like Keith is gonna be on top of it, when we get to that day, he's gonna be working on 14.2, 3, and 4. I know he is. And so if I open it up too early, it's just gonna flood his shit and he'll be fucking crazy. Heriberto's been fucking just all over the homework. You do not even wanna know how many hours that boy has logged over there. He's putting you all to shame. He's done like more hours of homework than like half the fucking class combined. Maybe even half the class that attends, not including Keith. Keith puts in a lot of hours. He's been fucking grinding on the work.
I think Keith is the one. Sure, he's been killing it.
When x equals 0. Y equals -3. when y equals 0. X plus 1 squared equals 4. So x plus 1 equals plus or minus 2.
Wouldn't it be the other side?
What?
Wouldn't it be on the other side? Because x was one, x minus one.
Yeah, when you look at it's minus, but the vertex is actually on negative.
What happens when you, I was quickly gonna find that when my y-intercepts, my x-intercepts did not fucking line up with the way. I was gonna quickly find that. So -1 and -3. Nope, +1 and -3. Yeah, I would have been like, what? I would have fucking found it, but thank you. This was strictly, or add the greater than and the equal portion. So it's got a solid line. If I plug in 0, 0, where do I get? I get is 0 greater than 1 minus 4. 0 is greater than -3, yes. So we're shading inside the parabola. Here I have y is less than -3x plus 2. Three over 1 should put it right there. I go up 3, left 1. It's over there, so I got a line like that, and it's dashed. And apparently they're intercepting way the fuck up there. You know? Way off my graph. If I check to see if 0, 0 works, 0 is less than 2. So we're shading over here.
The other intercept.
Right.
Really large.
So it looks like we're in this little inside the parabola below the line. Now, if I treat these as equalities. And then that's one line, and the other line is y equals -3x plus 2. These y's are the same, so I'm just gonna set them equal to each other. -3x plus 2 equals x squared plus 2x minus 3. If I move all the things over, I get 5x here. And minus 5. Damn it. I don't want to.
I can see that, it's like,
I knew it was gonna have nice points because of the way they met right there, but
wow.
That's 25 plus 40 is square root of 45. Over 2. Which is -5 plus or minus 3 root 2. Or 3 root 5 over 2. So the y value, I'll just plug that. I'm gonna have. That's one x value, the y value goes with it. Is 15 over 2, which is. And then add 2 is adding 6 over 2. I'll have 21 over 2. And then -3 times the 3 root 5 is gonna be minus 9 root 5. That should be one of the points. And you can find a decimal for those. If you want, and then we have the other one. It's still the 21. Over 2, this one's just got the opposite sign here. So those are the points of intersection. I would check them with a decimal version. And I'm seeing that if I try to test all these on one thing. I better have fucking make some points that don't have all this shitty fucking. Points that work well. Don't wing the problem on the test, Dave. Got it. Cause you don't wanna have this on the test. No. You'd rather have X show up as fucking -3 and 4.
Yeah.
Some shit that's like easy to fucking plug in. I don't know what those values are, but this one looks like. That one, nope, that one looks like it's pretty close to 1. It's just to the left of 1,0. And just below it. Any questions? Now it might throw in ellipses, it might throw in. Absolute values, it might throw in square root graphs. But it might throw in exponentials or logarithms. I don't know what's on the homework. It all just takes going through and being patient. 13.4 is just gonna have you check for the points. 13.5 is doing systems of equations, but they're just lines. The inequalities, they're just lines. 13.6 is combining both. So you'll do like this graphing here, but I don't think they're gonna ask you for the points of intersection on that.
So just the graph.
I think 13.6 should just have the graphing part. They might ask as a whole, what do you remember kind of thing, but. Any questions? Get back up. I think if we start another one, we're not gonna finish it in time, so. It's only 8 minutes left. Oh, wait, I'll keep sharing in case anyone needed that online. I'm just gonna stop recording.